Lesson 4-7, inverse linear functions. Our objective today would be to find the inverse of a relation and also to find the inverse of a linear function. So inverse is exact opposite. Inverse of a relation, you literally switch the x and y coordinates. So if you're asked to find the inverse of a relation where it's listed as a set of ordered pairs, then you are going to go ahead and write the set notation, which is like that. Doesn't have to be perfect, just do the best you can. And you switch the x and y coordinates around. So 26, negative 3, 11, 2, negative 1, 6, 20, negative 1. Just make sure that you write them in the set notation, that's part of it, and you write the ordered pairs with the parentheses around it. You switch the x and y around on every one of the points, and that's it. That's the inverse of that relation. It's the opposite. Next, finding the inverse of a function. Well, we're going to talk about these functions as linear equations and also with function notation. You're going to make them all linear equations with x and y. Okay, so if they're given to you with function notation, you've got to go ahead and, instead of that function notation, put your y in there. But you write the equation with x and y, then you write it and you switch the x and y around. You then solve for this new y, and that is called the inverse of your function. And the notation is f, and there's a negative 1 there. Negative 1 is the exponent. That implies inverse of that function. That's how you write that new notation. It has to have a negative 1 there. So when you see f of x, that's the regular function. And when you see f negative 1 of x, then you know it's the inverse. Okay, so we're going to look at one where we find the inverse. This first one is given to us in function notation. And it says f of x equals negative 3x plus 27. So since it's given to me in function notation, I have got to go ahead and substitute y in for f of x and put y equals negative 3x plus 27. If it is not in function notation already and there's already an x and a y, then obviously you don't have to do that step. It's already done for you. There's going to be both kinds given to you today. Some have the function notation at the beginning and you have to switch it to y, and some don't. Okay? Now, that's first thing. Make sure that you've got an x and y both in the equation. Now it says to switch them. So that literally means switch them. Y becomes x and x becomes y. Just like that. Y becomes x and x becomes y. And now you're going to take that equation and you're going to put it into the form of y equals now. My y is on the right, so I'm going to go ahead and leave it there for now. And I'm going to subtract 27 from each side. And I get x minus 27 equals negative 3y. I'm going to bring it up here so I have a little more room. X minus 27 equals negative 3y. Divide everything by negative 3. That means every term. So that cancels out. This would become negative 1/3 x, because in front of that x there's a 1 there. It's easier to write it like this, negative 1/3 x plus 9, they're both negative, so it becomes positive 9 equals y. Now I'm going to finish this off by writing it in function notation, but it's the inverse. So you're going to do f of negative 1 of x, and you're going to write what y equals, negative 1/3 x plus 9. So you make it an equation with an x and y, you switch the x and y, and you solve for the new y. That's the inverse of the original. Okay, second, f of x equals 5/4 x minus 8. Again, they've given it to us in function notation. So I'm going to put y equals 5/4 x minus 8. And now you have to switch your x and y around. So x equals 5/4 y minus 8. Add 8. X plus 8 equals 5/4 y. To get rid of a fraction with the variable, you multiply by the reciprocal. So that means on both sides, I'm going to multiply by 4/5. That takes care of the fraction on the right with my y. I'm going to go ahead and distribute that, even though it won't be nice. 4/5 x plus 32/5 equals y. I need to write it in function notation, and since it's the inverse, I'm going to put f of negative 1 of x equals 4/5 x plus 32/5. So basically you're going to be solving equations in reverse from what is there and writing it with the inverse function notation. Are there questions about that? Because I want to switch to the homework page. I want to show you something on there. Does everybody have that part written or not? Anybody not? Okay, so let's switch over to the practice page and let you see this. So the first 4, you're just going to switch your x and y around, write them as a set of ordered pairs. You set notation and parentheses and all that good stuff. Now, 5, 6, and 7. You are going to have to write the equation that is there. Okay? You're going to have to use your information like the y-intercept, the slope. You're going to have to be able to write the equation from a graph, and we've already done that once. A couple times, actually. Then, once you write that equation, switch your x and y around and solve for your y in the new part, and then graph that equation. I think you'll find it very interesting how the inverse should look. Okay, 8 through 13, they're listed as function notation already, but that just means for f of x, you're going to put a y there, and then you're going to switch your x and y around and solve. Now, on 9, 10, and 13, it's got the whole side over a number. How do you get that straightened out? What should you do, Jared? Yeah, multiply. For example, on number 9, you're going to multiply both sides by 3, and you'll have 3y. Well, actually, you're going to have x and y. You're going to have 3 over here, and then that's going to cause this 3 to fall out, and then you proceed from there. So 9, 10, and 11, you're going to multiply first, which is kind of unusual for us. 13 to 18. So it looks like on the first 4, you just literally switch your x and y around, solve for y, so those are in standard form. 17 and 18, do you see something a little different? What's different there? It's not simplified to begin with, is it? So you got to combine like terms and then switch your x and y. So they're just trying to throw a little more work at you there. So 17, 18, combine like terms first and then switch your x and y. 19, it's a good practice that you have to write an equation and function notation from this information. Do the inverse, and then they just want you to describe what those things mean in the inverse and what would make sense. So that would be a good one for you to work on there.